Okay, hey kids. This is Anakin and myself teaching you 9.2 mass calculations for reactions in chemistry. Goal here, if you're given the mass in grams of a substance for a reaction, calculate the mass in grams of another substance in the reaction. To convert mass of substance A to mass of substance B, we need the molar mass of the substance, which comes from the periodic table. Sorry about that noise. Molar mass we get from periodic table. Mole factors of substance A to substance B comes from balanced chemical equations. That is your coefficients. Also, you'll need the molar mass of substance B. Here's a flow chart. Grams of A, moles of B, back to grams of B. When acetylene burns in oxygen, high temperatures are produced that can be used in welding. Here you have balanced equation 2C2H2 plus 5O2 yields 4 carbon dioxides plus 2 waters. How many grams of carbon dioxide can be produced when 54.6 grams of acetylene is burned? So when you're wanting to get the massive product from the massive reactant, step one, you're going to state your given. They say needed, I say unknowns. So when I'm writing my unknowns, I draw question marks. Those question marks are questionable. Here's what we're given. Here's what we need. So again, here's your problem. Don't forget this means delta, which means that heat was added. When you write a plan, we're going from grams of acetylene. We're going to get the molar mass, which is going to be 2. Oh wow, that's terrible. 2 times 12 for the carbons plus 2. So your molar mass of acetylene is going to be 24 plus 2 is 26 grams. That's going to give you moles of acetylene. The mole to mole ratio of acetylene to carbon dioxide. We're going to have 2 acetylenes produce 4 carbon dioxides. Hello, Starman. Welcome to the party. Remember that.
I'm Starlord.
I think I just called you Starman. Well. Okay.
I'm your co-host. So please listen to my mom says and don't skip this video.
Thanks.
Study.
And chemistry is awesome. So here, our mole ratio is going to be, wow, my slide just went stupid. So remember that you could have this either way. You could have 2 acetylenes for 4 carbon dioxides, or you could have 4 carbon dioxides over 2 acetylenes. You're going to use the version of that cancels out acetylene and gives you carbon dioxide. So you're going to want the one with carbon dioxide on the top. So here you're just getting your molar mass. Again, you can use either version of this, but you want the one that cancels out and puts you in moles of acetylene. So you're going to want, oh my good Lord in heaven. So much failure in such a tiny amount of time. You're going to want this one here. Guess.
You want any like ranks or something?
Okay, picking back up. Here we have step 3 to write coefficient or use coefficients to write mole to mole factors. Write molar mass factors. 1 mole of carbon dioxide equals 44.01 grams of carbon dioxide. That came from the periodic table. 12 grams plus 16 grams plus 16 grams. That's where that 44 came from. Okay, step 3. You're going to use coefficients to write your mole to mole factors. Here, this came from your coefficients. Again, 2 to 4. You can use either version of these. You're just going to set it up so that you cancel out your given and you end up with units of unknown. Here is when you set up the problem and go all the way across. So here's our given, 54.6 grams of acetylene. Here we canceled moles of acetylene, and that changed it to the molar, that went from grams of acetylene to moles. The reason we did that is because then we can use our coefficients as ratios, change it from moles of acetylene to moles of carbon dioxide. That happened in this step. And from here, we went from moles of carbon dioxide to grams of carbon dioxide. This is our unknown, grams of carbon dioxide. This was our given, moles of carbon dioxide. Notice our given changed as we went across. So each time your given is going to change from before when you converted it. If you do the math, 54 times 1 divided by 26.04 times 4 divided by 2 times 44 divided by 1, you should end up with 185 grams of carbon dioxide. You can also do the math by multiplying all the way across the top. 54.6 times 1 times 4 times 44.01 divided by, open parentheses, 26.04 times 2 times 1, close parentheses, equals, you should get the same thing. I prefer to multiply, divide, multiply, divide, multiply, divide, but that's me. Either way is fine. That's the end of this problem. So let's just stop right there. Erase this. Recap. Balanced equation. You have to make sure that it's written in balance correctly first. I love you too. Here's our known. Here's our unknown. Here's our steps to get there. Grams. Use molar mass to convert to moles. Use mole ratio to convert to moles of carbon dioxide. Use the molar mass again of carbon dioxide to convert to grams. That's the end of our first example problem. We're all happy little chemists.